using glycans as a proxy for systemic inflammation and then also risk of future chronic disease and future mortality, it's a very good marker. And if your goal of a biological age is to reduce all-cause mortality and to reduce disease, then this is the best performing indication of age to do so. When we compare with other mortality predictors, we are much better without even modeling for mortality, especially on the level individual, because you need this reliable data where if you measure the same person the same day, week, months, you're getting the same result or reliable result that will move with biology, not with measurement error. The biggest extender of our longevity, health span and lifespan, is not going to be a pill. It's not going to be a drug in the short term. It's not going to be any intervention. It's going to be
Another day, another biological aging clock. With me today, the co-founder and CEO of Glycan Age, Nikolina Lauc. Welcome to the show.
Thank you. It's a pleasure to be here.
So, Nikolina, first things first. What's your story?
Hmm. Well, I think everything goes back to where I come from, my parents, and then how I got here. So we can start there. Some Croatian by origin, and I'm a daughter of two scientists. My mother's a neuroscientist, and my father is a biologist that specialized in glycobiology, which is this science of sugars around your proteins or lipids, but mainly focused on proteins and how they regulate the function of your protein. And he was obsessed by it from when I was born, actually. So my parents met in a lab where the lead scientist there was looking at, well, they had kind of the first tools to look at glycans, and they were actually looking at aging in the brain. So glycans and aging in the brain. And then
So your
glycans.
parents discovered glycans.
No, I mean glycans. So if you go all the way back to what glycans are, the first discovery of that they're important for a biological role was blood groups. So glycans in your blood cells give you a certain blood group, and this was a discovery 150 years ago. But then maybe 30 years ago, 40 years ago, we started having a bit more of the tools to look at them in the lab, and then in 2006, the pursuit of high throughput glycomics, or looking at the human glycome at scale as a part, same as we had the human genome effort, there was an effort to look at the first 1,000 glycomes in the world. And that was 2006. And that was between my father's lab and another lab in Dublin. They were the first in the world to look at the first 1,000 human glycomes then. And then they stumbled onto, or when they started these large population studies, because nobody looked at more than 10 glycomes. You would look at one glycome. Then they started to see trends related to aging, or they would start to study a disease, but then aging would have a stronger effect than the disease. So you can have a young person with a disease that looks like a healthy old person. So there's a healthy old person who has a profile of a young person with disease. So basically there was something driving disease and aging, and there was a story to tell about it by looking at glycans. So that goes back to last 20, 30 years. Now, I didn't follow my parents' footsteps. I actually went the complete opposite. I didn't want their careers because I was born in 1991, so that was the start of the Yugoslavian civil war. So Yugoslavia fell apart. And they were really young. So my dad was 20 when I was born. My mom was 24. So he was the intern in the lab, a really smart intern. And my mom was his boss in a way, or his, So that's how they met. And they had three accidental kids before he was 25. So it was this kind of super hard circumstance, middle of a war, both of them pursuing their careers and three little kids. And then both of them ended up in John Hopkins, my mom in a neuro lab, and my dad was working with a guy who was best in the world in glycan analysis at the time. And actually, my mother's PI, he was looking at Alzheimer's disease for glycans in the brain. So it was all kind of going back to this field of biology. And growing up, I took a different path. So I always had a bit of an entrepreneurial streak. So I had little ventures since I was a kid, even, if you want to date it back to kindergarten. And I'm also dyslexic, and I just didn't, I didn't pursue the pure academic path they did. I started in business very early. So I started my first company at 18 years old, and I spent the last, now almost 17 years in startups.
So this is still in Croatia?
First company was in Croatia, and then I went to university in London. And built a startup out of university. So in my last year of university, we had a company that was making over $1 million, and it was actually the worst year of my life because there was the getting your degree. I was doing engineering on the side, or teaching myself how to code, and then there's a startup, a full-blown growing company. So my path is that of an entrepreneur, and I spent 10 years in tech as a focus, and did really well, with, of course, lots of painful lessons. When you're an immigrant in your country, you're doing something a little bit crazy, or you're very young, but bold and ambitious and persistent. So you do well, but you learn a lot of, there's a lot of hard lessons along the way. And then, so my father told me he found a way to measure aging on a systemic, molecular level 15 years ago. So I was 19 years old. And I didn't see the point of it. I think because you're young, you don't care about aging. But also, I was telling everybody I'm 25, or I was hiding my age. I wanted to think that I was, and I looked much younger, and I still look a little bit younger. So it was always a little bit confusing. I was always, ageism was my problem growing up. Ageism in the opposite way of you being too young to do a certain thing in life. So then he spent about 10 years, every couple of years, pitching me to do something with him. So he would say, look, this can be applied to people. It can be, because he has a private research institute, it can be something that can be commercialized. It can be a venture. Let's do this together. Let's do a business. And every time I said no. So he would, I was doing really well on the other side, and I kind of wanted my own path for a period of time. And then about 2020, or even 2019, I dived a little bit more into the science with him. I was like, okay, what is this glycan thing you're obsessed with your whole life? Let me at least understand it, and then I can judge it better. And he had a really good pitch to me that was, do you want to continue helping people buy things online easier, which makes good money, or do you want to do something that nobody in the world can do right now? So this was kind of that. And I did spend a decade kind of focusing on the financial pursuit, and I was bored. I got to a level that just, I don't need much in life, to be honest. So after a certain level, it was boring. And I wanted a new challenge, and I was also finally ready to work with my father. So I went all in 2020, and we started this as a commercial venture, but of course it has a lot of scientific pursuit behind it, and a lot of also path to routine healthcare, which is, I think, healthcare entrepreneurship is a bit different to the pure commercial pursuit. But that's a gist of it, and I'll stop here. And
yeah, it's a perfect place to stop because we can pick that up. Because I bet there are stuff happened even after you started your last company, right? But you see, well, just a couple of things, because there are a lot of parallels between my path and your path. Just starting in there, that you born in 91. I was born in 91. I was an entrepreneur throughout my entire career. I'm in Hungary, right? I grew up there, and you grew up in Croatia, which is next to each other. So, wow. Even the ageism, you know why I have this beard? Because
To look older.
I was developing a Bitcoin wallet, and 20 something year old guy and billions of dollars were stored on or are still stored on that wallet, right? So
Yeah.
I had to grow some authority, like a Linux developer or something. Had to look like a geek. So
Yeah.
that's exactly why I started. And now I don't even know how I look like anymore. I'm afraid that if I wouldn't recognize myself,
No,
if
it's
I ever
good. There,
cut.
there's like a few nice grays, so now you can, I still honestly, I'm 34 this year, and I like to say I'm just above 35. So I'm not negative about a chronological age going up, but kind of knowing what's happening with your health through time is a different pursuit, and also, yeah, how can you use your life, in the best way in many directions.
Yeah. You see, the other thing that you just said, that your most recent pursuit is more about meaning than about like a good business, which are not exclusionary. In
Yeah.
fact, a good business is okay. You talked a lot about entrepreneurship, and in fact my previous guest, uh, John Sabes, he was one of the guy who was trying to bring biological aging clocks to to some legacy industry of in insurance, right? He did not succeed, but he was an entrepreneur throughout his entire life, right? And he's 60 right now, something like that. Anyhow, he talked about the a book from the Square co-founder. Square and Jack Dorsey created the
Mm-hmm.
company. Sorry, uh, the co-founder of Square and Jack Dorsey created a company, and I don't remember his name, but it's a great book. I just started reading it. It's Innovation Stack, and he talks a lot about, like, okay, what's the difference between an entrepreneur and a businessman? Okay, let me ask you this: what's the difference between an entrepreneur and a businessman?
Oh, I well, I think I can tell you what's the difference for me, because I can say that I'm always true to being entrepreneurial, but it doesn't always need to make perfect business sense in a way, and that's probably more focused on the problem solving, um, but also, and then I think if you say crazy pursuit for some goal that's not possible today, you can apply it to beyond entrepreneurship. This can be athletic, but I think in if you say pure business, and there's probably better ways to describe all of these things. Pure business, sometimes in the short term, the decisions which are short-sighted or gains in the short run, so making short-term economic gains, or reaching whatever um, financial short-term goals. Sometimes these come at the expense of a long-term vision or a long-term goal. So I think if somebody's purely business-minded, they might just be optimizing for one thing, which is good economics. While if somebody's entrepreneurial, then I think this goes beyond just the good economics. Good economics are part of it, because businesses don't run unless you can, pay a good team, raise investment sometimes, and have customers. But I think they can be way beyond pure financial, and it is actually a much more meaningful and sometimes much more longer aimed goal when it goes beyond the financial, or something that's true to how do you fix this problem in the world.
Right. So being a businessman is boring. and an entrepreneur isn't. You see,
Yeah.
let me share you this because, man, I've read like 100 different biographies and about businessmen and entrepreneurs and stuff like that, and I never realized the distinction. But now that I'm reading this book, it just clicked to me. So the short answer is that an entrepreneur solves a new problem, but the longer one is more interesting. It's like imagine a town, a city in the Middle Ages. So you know this there are streets in the city were very narrow, and on the bottom it's like a shit sewers are going on the bottom, and the people are walking there because like there is nowhere else to walk. So if you fall, then you have a problem. But the thing is that people were even though they were literally walking in shit, it was still better for people to live in the city than to live outside the city, because outside the walls is cold, right? It's like you might be starving, you might be predators are coming after you and stuff like that. So what's the difference between an entrepreneur and a businessman? A businessman is the one that's running the city. An entrepreneur, the one who's living outside the city, right? Who is willing to take the risk, the leap of faith, and try something new. And I think that's what you're doing with GlycanAge as well. I want to ask you about GlycanAge as a company, but first, I just I just wanna understand what what is a glycan?
Yeah, that's the ultimate challenge to simplify this in a way that can translate. So they're complex sugars, but they're complex sugars not in a sense of how we think of sugars today, because you often think about the simple carbs or the sugars in your diet, or maybe even the sugars from your diet that damage your proteins, which then leads to diabetes. This is called glycation. Um, Glycans or glycosylation, the process we look at, is partially encoded in your genes, is influenced by your epigenetics, meaning it takes all these epigenetic changes that happen from when you were in your mother's womb to today, happens post-translation, so once the protein is made, because all proteins are encoded in their DNA, which doesn't change, and then these glycans or these complex sugars, which are added on top of your proteins, add function to this protein beyond the genetic epigenetic background and taking in feedback from the environment. So they're the final fine-tuning we have in biology to enable multicellular life. So if we look at every process in biology since we were single cell and we became multicell, all of it is mediated by glycans. So I can give you a few examples. One is the blood group, so defining, and that was the first discovery we had for personalized medicine. You have to do the right blood transfusion, otherwise a patient might even die. Then they play a key role in every process, from conception to all immune communication to cancer biology. Every all cells are coated in glycans. Majority of proteins are actually glycoproteins. They don't function without the glycan part. And majority of lipids are actually glycolipids, and we know nothing about glycolipids. We know very little about the space. So they're a key part of our biology. That's a carb, but enabled our biology to communicate on a multi-cell level. So there's a paper my father published over 10 years ago now that says that glycans are the third revolution in evolution, or they're the step that we needed to become. Because, if we just look at genetics, there's not much difference between a human and a fly. So 22 pieces of DNA in a human, 20 or 25 up to, actually we haven't defined it, or 20 in a fly. So human fly, pretty much same thing if we look at the amount of DNA. But on a glyco level, it greatly increases the complexity of our biology. So that's the kind of final complexity on this omic level: genomic, proteomic, glycoproteomic, and then other spaces as well. But that's a relatively simple way to explain it. But then let's go a little bit more simple, because we focus on a certain part of glycans, and that's mainly in terms of immune communication. So you can also call them immunoglycans or immunocarbs, where their main job is regulating systemic inflammation. So that's actually how we study glycans, and you can study them in many areas, but they regulate how your immune system functions and how it communicates with the rest of the body. And on antibodies, they would make your antibodies more pro-inflammatory or anti-inflammatory, and in this way regulate inflammation on a systemic level. And that's what we see changes with aging. It's actually a particular process or immune aging called inflammaging, where the background level, or our ability to control inflammation, deteriorates with time, and we create this background systemic inflammation, which then leads to a whole host of different diseases, or majority of chronic diseases. So far what we know, about 60% of chronic disease goes back to chronic inflammation, or this kind of one systemic level of aging and decline. How complicated was that? Or because
It was super complicated. I have
okay.
to find a different angle on it, because okay, so glycans are like sugars, but not exactly. They live
Complex sugars.
inside complex sugars. They live inside your body, right? And around your DNA, where are they?
They're around your proteins. They're
Around my
also,
proteins.
yeah,
Uh-huh.
they're also around your cells. They're also around your lipids or your fats. So they're basically everywhere in biology.
Aha, aha.
But they're like a language which enables biology to communicate. So let's think of them as a language, but they're a sugar language. So internal sugar language in our biology, that's encoded in our DNA partially. So it's not fully, so they're complex traits. So your proteins are fully encoded in DNA, and the glycans are inherited as a complex trait. So they take in the genetic background, epigenetics, which is how your DNA has changed through time. So turning on and off certain SNPs, and then incorporating environmental feedback as well. So let's say that there's something that helps us understand how our biology, or how are we communicate with our environment, connecting our genetic predispositions or backgrounds. So if you look at them so they're a really nice way to see what's happening with their biology through time. So let's put that as a way to think about it. And then also there's something in between disease and the genetic potential. So they're somewhere in the middle. They're a pre-disease. They would indicate pre-disease states where we can see that your biology is going towards a disease endpoint, but it's not like a genetic risk that won't change through time. It's a glycan risk that has changed through time and can change backward. So we can indicate that you're at risk of a disease in 10 years' time by looking at your glycosylation pattern. And that's the point where you can prevent the disease, versus what we do in healthcare now. We wait for an endpoint, or you have a certain disease, and then we try to, we try to balance it with different medication, but we never bring you back to health, because it's most of the time already too late.
So let me ask an even, possibly even harder question than that, because we're going to talk about this. I wanna talk about the inflammation part, but firstly, um, give me an intuition about inflammation. Like, sure, I feel hot, but what's inflammation? Because it's a topic that, um, I don't know, oversimplified but extremely complex somehow. It's like you want lower inflammation, but but when you're working out, your inflammation is high, and now it's good. Yeah, okay. So inflammation. What do you know about inflammation?
So you're completely right. It's a very complex topic that we simplify a lot, and then we lose a lot of the meaning by simplifying, because there's many different types of inflammation. And even on a chronic or acute level, again, there's many different types, and the immune system is so complex. We're nowhere near to fully understanding our immune system. So if you talk about sports, you want acute inflammation after you've been at the gym, because that will trigger the building of new muscle. Or you want inflammation if you have a bacterial or viral infection and you need to respond to it, or even if you need to kill cancer. So it can be extremely valuable, both in acute, meaning over a few hours, days, minutes, or in a chronic sense. But let's simplify this a bit more. Let's say that acute inflammation is good because it's something that will keep us alive in the short term. So it's designed to optimize our survival in the short term. Chronic inflammation becomes bad because it goes beyond the short-term survival and it compromises a number of different systems to kind of improve short-term survival for the expense of the long-term survival. So, and then again, we can think of it, you probably know what homeostasis is. This is kind of like perfect balance of an organism. And for that, we kind of have an optimized immune function. And then loss of homeostasis would be chronic inflammation. But if something is a acute stressor, like hormesis, so you exercise, you fast for a day, or you even have some extreme stressor for a few hours, whatever it is, bungee jumping out of a plane, these are not bad things because they're acute. They're going to maybe even strengthen your system and prepare it for the next acute event. But if they linger for too long, they turn into a problem. So I think the way we're starting, because we did a lot of stress research, or my parents did 30 years ago when the Yugoslavian war, and stress was a big thing. And then they stopped for a period, and now we're doing again a lot of stress research. If we think of what causes our system to decline long-term, our biology, it's potentially our stress response. And here we're very different to other mammals, where usually after a certain stressor, they completely relax and go back to baseline. Well, humans can be under chronic stress because they hate their job, or because there's an imaginary threat in their head. There's no actual running from a lion. It's all kind of how we respond to something is more important than what it actually is, because very rarely is our life actually threatened. So if we're under acute stress, we don't need to use our immune system. So we don't need to fight bacteria, viruses, or even cancer, because for these 2 minutes, we're designed to run from a lion. So we don't need to fight any of these things in these 2 minutes, because we're supposed to go to baseline afterwards. Then we don't need to reproduce in this period, so our reproductive system gets suppressed. Our immune system gets suppressed, our reproductive system gets suppressed. And we don't need to digest food in this period, because again, you're running from a lion, put all of your resources into immediate survival. If you do this chronically, you're chronically suppressing your immune system, your reproductive system, your digestive system. And that's where most of us break nowadays. It's really the kind of compromise or this pressure on these systems with long-term stress, then leading to chronic disease, chronic inflammation, and shortening our health span. Because if lifespan, the maximum lifespan, we don't know how far it goes, but here it's 120, 122. That's the oldest record. But
Do you believe that? I mean, do you believe that there is a limit there?
In a theoretical sense, potentially. And it could be 150, but very few people get there because the average life expectancy is 74 or 80. So this gap between 74, 80 to 122 is huge. So if there is a limit, again, the problem is that very few of us are getting there. Way less than 1% of people get to this limit, one person to 122, but a couple hundred, or maybe now there's thousands to 100, 110, so forth. Why is that? But like you have so many different aging theories, and nobody's proven any of them yet because they're still, it's such a complex system. It's going to take us a long time to prove these theories. But the two leading theories is that aging is a program. Hence, we should do reprogramming therapy, and maybe potentially this can even extend their maximum lifespan or double it, or that aging is damage. It's continuous damage, an accumulation of this damage for time that leads to the loss of function and disease and mortality. And potentially both of these are true. Because one, I quite like Steve Horvath, who's the mathematician who went into epigenetics and did many different clocks in this space. But there was a talk he did about a year or even more now, when he was he's made different clocks to predict maximum lifespan, to predict when you're going to get disease, to predict mortality. And this maximum lifespan clock he replicated in hundreds of mammalian species. So there was something governing maximum lifespan from mice to whales to humans and so forth. And then he was correlating these clocks. So he was correlating the maximum lifespan with the clock that predicts disease or that predicts death, and they didn't correlate. So
they did not correlate?
They did not correlate. So what was driving the mortality or disease is different to what's governed in this maximum lifespan. So I think both the program theory and the damage theory are correct. It's just a complex system that has many different things going on at the same time. And if we're going to get to some crazy life expectancy, we're going to have to work in many different areas to figure it out.
Well, that's what we are doing right now. Thanks for these explanations. This will be necessary for where we are going now, because now we are moving on to Glycan Age as an idea, as a company, and as a biological aging clock. Were you there from the beginning, or is this your father started to work on Glycan Age and then you joined in and started the company?
It's my father's life work. So he was working on this or working on glycans for as long as I have been alive. And then I joined into this pursuit when it started to reach people, or when we brought it to a stage that it can be applied to some.
So, I mean, not only just Glycans, on Glycan Age specifically.
Glycan Age. As a clock. So the first time he published a clock was 10th of December 2013. And that's actually the same date that Steve published his Horvath's clock. Same date, 10th of December 2013.
Same day?
Same day.
Okay,
same year.
and were there some synchronization or pure coincidence?
Pure coincidence, yeah.
All right. So, what was the thing back there? There was the Hanum clock, which is older, right? Yeah, I don't know. Was there anything else? There must have been some.
Well, the first theory of aging was telomeres. Measuring telomeres, and then, and of course, these were ideas on how we can understand, measure aging. And with telomeres, what became clear is that they're more relevant to single cell aging, and we have trillions of cells. And if we look at more systemic level aging, it will be something else. So this is why the other clocks came along later on. I think definitely more attention was on epigenetics for a long time, because they're pretty close to our genetics. So understanding from genetics to epigenetics, much easier, simpler to translate, even from tools in the lab to just general describing what it is. And then glycomics have always been a neglected space because there wasn't as much of we had the moonshot of sequencing the Human Genome Project, which kind of took over all scientific focus because it became like going to the moon. Let's sequence the human genome, which meant that we ignored all the other parts of biology. And then after we did the whole pursuit towards the genome, we understood that genes don't define everything, and they're not the key in what makes us ill or what makes us live very long or short. There's a lot more complexity in our biology, and we have to see the full picture to understand it.
You see, there is the entrepreneurial opportunity, right? The place what other people's ignore or don't believe in, but you strongly believe to be the case. That's where you find your opportunity.
Yeah, well, that was my dad's obsession, and especially when you're pursuing something nobody else does, there's a lot of skepticism. There's a lot of it's a really tough space to be. He did a huge amount for this space of glycobiology. His institute looked at more human glycans than the rest of the world combined, and he started the Human Glycan Project, and it's very hard. And then eventually, I decided I want to do something that's really, really hard. But yeah, on the financial side, it will come in the future. But that wasn't the number one reason I joined, and it was also to continue his work because it reached a different stage, and it was time to take it beyond the lab.
So GlycanAge, did it change since the initial discovery, like the algorithms?
The algorithm, actually, no. We expanded the baseline. We never changed the algorithm because it works. And we validated it on many different applications, and it's valuable exactly as it is. What we did do, we added different indications. So we have now a test, or now we're preparing it for regulation and for hospital use to predict heart attack and stroke by looking at certain glycosylation patterns, or to predict diabetes 10 years ahead of time. To detect menopause in the early stages. And now we're also working on, so similar to Steve's Grim Age, we developed a very good mortality predictor, but what we're doing is we're flipping it on resilience. So it's not to tell you what is your risk of mortality and disease, but to tell you what is your resilience towards mortality and disease. So it's a positive flip on, yeah.
Oh, so wait. Okay, that's interesting because the evolution of biological aging clocks were first, let's just correlate it with biological age, right? And then we changed to, well, let's correlate it with all-cause mortality. And now you're trying to correlate it to all-cause resilience. That makes no sense. So okay. Don't help me yet. I'm trying to make sense for it by myself, and then you can tell me where I'm wrong. I wanted to build a exercise program, a longevity specific training, and then I was looking at, okay, so what should be my goals here, and where do you start? Well, of course, you start with the current scientific paradigm, the hallmarks of aging paper, right? And I was looking into the hallmarks of aging paper, and I realized that, you see, this is a very narrow way of looking at aging, because it's like people are gonna fall, right? A lot of people are dying because they fell. Of course, they get frail and everything, but ultimately they fell and died because of that. But the hallmarks of aging keeps that completely out of its context. So if I want to introduce some kind of how to fall properly training, then I cannot use the framework of hallmarks of aging. In fact, it's much worse, because don't remember the details, but the hallmarks of aging not only focuses on internal aging aging factors, but it even constrains itself to more things. So anyway, I'm thinking about resilience in a similar way, that now you're not aiming for all-cause mortality, but you might actually find a better aim to correlate it with. Does that make sense? I still don't understand what resilience. What do you mean by that, though?
So I think when we talk of these markers in the endpoint, so I think the distinction is, or the refocus of resilience, and this is, keep in mind, this is a very new concept that's kind of just coming out now. Most of the biomarkers we look for are disease oriented, or okay, you can say even organ oriented, but let's just say disease oriented. So when we study biology, we're trying to study disease, but we're not studying what keeps us healthy and what prevents this disease from happening. So that's the idea of resilience markers. Can we find the markers that actually help us, make us resilient to disease and mortality? And of course, they're going to correlate with mortality and morbidity, so prediction of disease, prediction of mortality, but they're going to be so early where you are predicting this risk 20, 30 years ahead of anybody having a problem, and you're just measuring your resilience through life and then optimizing for that, as in a place where your biology is still fully healthy, but your resilience might be going up and down depending on how you live, where you live, what's happening, your stress response. And then that gives us continuous feedback, which is separate to disease. So there's no bad connotation of, oh, I'm going to develop cancer, diabetes, whatever it is. Or maybe there's no even a connotation of the particular predisposition. It's just kind of like, where is your resilience to a whole bunch of disease and mortality, and how do you move the needle on that through life before it becomes something different?
Is this your concept or?
No. This is this is actually my father's concept. So,
Okay.
and it's his new obsession. So
Uh-huh.
he's a scientist. I think we have similar and different curiosities, and his are sometimes purely scientific, and mine are sometimes quite humanitarian. So I like to think about this impact on people, or this translation to people, or even psychology is a key thing I like to explore. For him, it's sometimes pure biology or biological concepts. And there was a review in Nature Medicine by the editor of Nature Medicine that was calling for scientists to start looking as resilient markers instead of disease markers. So that was quite recently, a few months ago. And then from the mortality studies, we're publishing 3 mortality studies now where we predict all-cause mortality on the level of an individual. And actually every extra year of Glycan Age is a 10% increased risk of all-cause mortality in men. And in women, it's a different story, but let's leave that complexity for later. And then he realized this is the wrong way to look at it. And we should look at this decreasing the susceptibility to mortality and disease as the main pursuit or endpoint versus the actual prediction of mortality, because it's always negative. It might be something that's happening in the future, but you're always looking at something that's inherently negative. Well, if we and the use case for that, of course, scientifically, where we want to explore it is elite high performance, army, navy, sports, because there you're pushing the limits of what a human body can handle, and you want to optimize for performance, but then also not compromise the long-term survival and so forth. So yeah, that's but it's a new thing that yeah.
Okay. Look, enough teasing. Would you mind continuing your story from the time? Yeah, let's say the founding story, the origin story of your of the company GlycanAge?
Well, then let's start with when I started using the tests, which was 10 years ago. So when I was 24, I did my first biological age, or like an age. And this was way before we started the commercial company started in 2020. So this is 5 years ago now. And at that point, you went into my dad's lab, then you gave a vial of blood, and then 6 months later, a PhD student gave you a number,
Oh,
which you
so wait.
yeah.
Okay, I wanted to. This is important. So, what are we talking about here? Are we talking about a vial of blood, a blood spot card, or even saliva?
Oh, now I'm talking about 10 years ago. So 10 years ago, it was a vial of blood.
Uh-huh.
Now it's a blood spot where we look
Uh-huh.
at it's not the one blood spot, we look at four because we do every measurement in triplicate. So we analyze it 3 times to monitor ability. And if we see any, we analyze the fourth one. So this is just precision and optimizing for less
So
than
I
1%. Yeah.
have to fill out 4 blood spot card from the kit that you're sending. Uh-huh.
Yeah. And then very happy to send you one so you can
Oh
track it as
yeah, I'm very
well.
happy to receive one.
Okay.
Just I have like freaking 5 biological aging clock stuff. I'm always waiting for. I always want to test when I'm the half. Yes, but it just never happens. Okay.
Well,
Thank you for the offer.
yeah, and we're running a study on entrepreneurs, and we're comparing investors as a control, where we're tracking entrepreneurs for 10 years to measure the impact of stress, or we're calling the biological cost of entrepreneurship. So I can
Oh,
send you
that's
details
very
of the study.
interesting. When you're ready, please write me because I would love to not just read it, but also like interview you about this. That's on my yeah. I want to hear about that.
Perfect. Now I'll send you the details for it. Okay, so going back to kind of origins of GlycanAge and then how it goes into my story. So I did my first one 10 years ago, and it was a good read. It was in my 20s and I was 24, so I was 21 or something like that biologically. And I've tracked that for 10 years since. It used to be once or twice per year. Now I do it every couple of months. And I was skeptic number one. And actually, when it's something new, that it's a good
How much did
response.
it go up and down?
I can show you the graph.
Mhm.
We can upload it later. Maybe let's not start with that, but I'm happy to even if you can do it on this platform, I'm happy to share it. And but I think it might be good to cover some more ground before we get there. But I am the most tested, the most GlycanAge tested person on
Ah,
the
yeah,
planet,
nice.
alongside with my dad, who also does it almost as frequently, but I do it even more frequently than he does. And actually gives me more feedback than it does to him,
How
because
often do you track it?
every 2 to 3 months.
Oh, I thought it's like every third day or something.
No, because it's glycans and antibodies. So glycans control the half-life of the antibody, which is around 21 days. So you're not going to see
So,
anything.
aha.
Yeah. In very rare cases, so this is not eating, fasting for 3 to 5 days, or severe COVID, so severe acute disease, you would see it accelerate. So then they'll accelerate the half-life, but these are very few reasons why you would see an earlier change. Usually it does not change for weeks and months, and even years. When you're tracking it, it can be quite stable. And then there is a difference between men and women's immune system. Think of it as immune aging, and a lot of it is influenced by hormones. And women seem to have less inflammation compared to men prior to menopause. And when they lose their ovaries, or their ovaries lose function, they rapidly age. So there's this also interesting kind of hormonal differences connected to the immune system. And we can tell the gender of the immune system 100% by looking at the glycans, but of course you can also manipulate your gender with hormonal interventions. Okay, so going back, so I was the first skeptic that was testing it on myself. and then testing it a number of close friends to see what it is. What does it tell you? I had a gazillion questions for my dad, and every now and then I'll call with another question. And of course, there's a lot of science. So we have a research institute with 60 scientists, and we publish 30 to 40 papers per year in many different areas, from glycans in the brain to cardiometabolic disease to different aging models. Like it's very vast of the areas we look at. But then around 2019, 2020, it was the right time for me to leave what I was doing then and to go into this full on. And I did the classical thing an entrepreneur does. I had some savings from the previous ventures, and instead of buying myself a big house in London, I put everything in the business, and didn't take a salary for years, and took a lot of my previous team on the more software tech side and combined that with my father's scientific team, and we created I don't want to say just commercial pursuit, but a pursuit to bring glycans to people and to healthcare, in starting with measuring aging. And I think even until maybe a couple of years ago, measuring myself, I got to the point that I called my dad and I said, this really works for my biology, and what's interesting because scientifically we looked at more than 300,000 human glycans in different population studies, clinical trials. There's so much you miss when you do science because you don't meet the end human and you have no idea who this random, anonymized, you have some data, but you have actually no idea about the person you're studying on the other side. And when you meet this person in real life, you find a lot of interesting things. And we can talk about some of those. So one of the early things that we realized has a huge impact on your glycan aging, that was maybe 2022, and then we published some more papers 2023. We even submitted a patent to detect these early changes in perimenopause. So before, as women are, so we had a lot of clients who were around 45 to 50, who would start off with a good immune age. They would look great. They'd be really happy. They're like, wow, I love your test. It's telling me in 10 years, 20 years, my immune system functions, much younger than it's supposed to. It's great. And then we measured them a few years later, a year later, and all of a sudden, things start to go up. It's accelerating. And then the data we had before is that we see inflammation go up around postmenopause. We just called it menopause because we had numbers, dots, between a certain age. It was like, oh, okay, this gender difference we see, it must be related to menopause. But we actually had no idea how menopause happens. And as we started talking to clients, our consultants, because we decided we're going to keep a human element in the testing, meaning every test comes with an optional consultation. If you have a bad result, we might try and force you, like say, this is mandatory, you really need to talk to somebody, because we want to deliver the news as gently as possible and give you an action plan and manage this emotional response to it. But we decided to have this human interaction, which also helps us learn about the human being on the other side. And then our consulting team started to ask questions of, so we see that your age is going up. Are you cycling regularly? Are you in menopause? And they would say, no, I have a perfectly regular cycle. But there might be some other symptoms going on, or sometimes even pre-symptoms. We can see that chronic inflammation is going up. And that happens sometimes 10 years before you lose your final cycle. And menopause is a diagnosis when you lose your final cycle. And I won't bore you too much because I think you have a lot of male listeners. So I'm going to try and balance it out to talk about male hormones as well. But that was interesting that the assumptions we had in science were actually quite different when we met the inhuman being. And we had some discoveries. So hormones became a thing we started to study. And now, if you talk about longevity drugs, what do we actually have that we know that reduces all-cause mortality that's used in practice today. I mean, you're going to find a lot of hype about new drugs, like the weight loss drugs, like metformin, metformin is not a new drug, but you're going to find a lot of hype about a lot of drugs that don't have a lot of evidence yet, or they're in animal models, and there's no long-term data on people. On estrogen in women, we have long-term data where we tracked women for long enough to know exactly how much the drug reduces their all-cause mortality. And if they start the drug early around menopause, it's a 40% reduction of all-cause mortality. So if you're thinking about the most potent longevity drugs we have today, estrogen is right at the top of that list where the evidence is. But there's, that's a space that, there is a lot of political and some bad signs that gave a bad rep to hormones overall. And the long-term data is just kind of recently coming out. So we can start to look at it differently and make different claims. For men, it also looks like it's estrogen. But estrogen that you get, but let me finish it and then you can ask the question. The estrogen you get from testosterone, because testosterone converts to estrogen. And men have to have a healthy level of estrogen. It's not just a woman's hormone, it's a man's hormone, just at a different level. The proportions of them are different. And actually, post-menopause, women have less estrogen compared to men because their ovaries have lost function and they're not. So they're, what we saw in placebo-controlled trials is if you block testosterone in a man and then you give them back testosterone, but you don't allow it to convert to estrogen in a healthy level. So you block something called aromatase, which is what bodybuilders do because they want to over bulk on T, and then they actually do harm, and we would see this as pro-inflammatory. The immune system is purely pro-inflammatory from this intervention or this change. Well, if you give them back testosterone and you allow it to convert to estrogen in a healthy level, then their immune system becomes very anti-inflammatory. And some of the most proven interventions for GlycanAge is hormone replacement, both in men and women, but it should be replacing what you've lost. So when you are young, you have certain levels, and then as this starts to decline with age, that's when you're putting this back in so that your biology and immune function is one key thing that changes, functions as if you're younger age. And for women, we know it reduces all-cause mortality. For men, we don't have the data, but the data that's being collected so far is that potentially testosterone is also really having a similar mortality effect in men. And actually, a very small proportion of the world is using these drugs. So globally, 5% of women are on estrogen hormone replacement, and for men, it's less than 1 to 2%. And of course, it shouldn't be abused. So there's ways to abuse the drug, which we know, which is from the doping industry, which you would measure as negative. But there's also ways to use it as a longevity drug that could have a very good long-term impact. So that was one early feedback from practice, but I let you ask the question because I keep talking and then.
What other things improve your GlycanAge? Supplements. Let's start with supplements. Maybe we can go on to interventions later on.
Now, supplements, there are some things that work. So we have, but we won't make a claim on any supplement until we have really good placebo control trials. And for that, again, these trials are very small, so we would need to repeat them. But there was a trial with...
You can just whisper them to me.
No. So we did one study with cardiovascular patients with omega-3 fortified eggs, which had a positive impact on your glycans, not huge, like a very small amount. And then we had one very nicely designed, placebo-controlled, double crossover, so same as you would develop a drug, a trial with 25 or 30 people with NAD boosters, a company called Nuchido. And there we saw...
Older people?
They're human trials, yeah.
They are with older people?
No, this had a range, I think, from 20s to... So it had I probably would have worked even better if it was older people because there's more loss of NAD with time. But this was a broad range, and the effect was small but significant, 1.26 years within 1 month of intervention.
That's decent.
Yeah. Now, if you compare it to testosterone and estrogen, the loss of both accelerates your aging by 10 years, and the reintroduction or rebalancing of hormones reduces your glycan age by 10 years. So, 1.26 compared to 10 years. Hormones are a very impactful intervention. I am not a huge believer in out supplementing longevity. I think there's a lot of hype on a lot of supplements, and supplements can also work as drugs. They can be as powerful, but I think when it comes to we're measuring this background inflammation, actually the stress response and the mind is gonna give us the most. And we can go just purely to positive stressors like fasting. We did lots of studies with caloric restriction, which reduce your glycan age significantly even after 2 years of caloric restriction. There was a really nice study that was published in Nature with our group and in another group. And we did caloric restriction in 3-4 different studies with twins, with people preparing for certain diets. So we know caloric restriction predictably works in the majority of humans. If you put them on particular diets, then you have some people respond to a certain diet, other people respond to a different diet, and we haven't yet found the perfect protocol for personalized diets. Then going on to stressors, acute stressors. The best data we have now is on fasting, so 3 to 5 day water fast, no food. We did one smaller cohort. We did another one now, and we're collecting a big cohort, a couple hundred people.
This is an overweight people or
No,
like normal body weight people
normal BMI
works as well?
but
Because you
yeah,
can imagine with, like, let's say
yeah,
me, if I go on a 4 days fast, then I'm going to lose a lot of fat, and that will not
yeah.
do as much inflammation as it did, right? So, but I'm not sure about like normal people, like if they don't have a lot of inflammation to begin with, at least not because of the fat.
Yeah, so I think this is a place to explore, but the first study, the majority of the participants actually were within normal BMI range, but normal BMI doesn't necessarily mean normal. There could be, for different people, different. The BMI is not just the perfect measure, and there could be a lot of visceral fat, although you don't see it, and there could be a lot of uh, what you call healthy fat, or the kind of the which is not necessarily so bad, especially in some people. Some people can be very healthy and be pretty high on BMI, and it doesn't. It's not a health hazard, so it's a very individual thing as well. But they're not just high BMI, and it does seem to be something that goes. What we think it will go to is these acute stressors. Now we see the change happens right. So the glycan change happens much quicker than we see in other interventions, meaning within a week. But it also does go back to baseline after a certain period of time. And what we want to study is if you have these stressors multiple times, can you maintain the positive change for longer? And I think that's the biggest quest we have there, is to understand that all these, going from stem cells to whatever acute interventions, if they're going to make a difference in the long run. Because we did the plasma exchange studies, and we did see some changes after positive change maintained after 6 months as well.
I believe I've heard your father saying that Glycan age, that we should interpret it as the age of the glycans instead of a biological age. Does this make sense? Am I even quoting it properly? Or
So GlycanAge is a ultimate simplification of your glycome. So the age is a simplification of your glycome. And then what it means, it's a proxy for future risks, mortality, morbidity. And that's where we build up the evidence, not just in large studies, but also on the level of individual. So it's a type of biological age, but we haven't yet reached consensus on what is a biological age or what is the optimal way to measure it, or if there's a number of different biological ages. So biological age is a concept in a way to simplify our biology's decline with a simple number, or a simple number we can change. But the ultimate meaning of it, it's your glycan age. So it's you plotted on this data set of 300,000 human glycans and us telling you how old your glycans are compared to how old they should be. And it's a representation of this systemic inflammation or this inflammation that's accumulating for time. So it's a type of biological age, or that's a simplification, but reaching consensus on what biological age is going to be a very long pursuit.
Well, yeah, as we talked about it, the concept of biological age from a purely conceptual, scientific, or philosophical point of view has failed. So because it didn't fail, but the 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 biological age would be the correlation with chronological age, right? And it failed in the point of view that is not a very useful metric. We much rather want to have something like correlation with all-cause mortality, or correlation with peak performance, correlation with most healthiest person ever, right? That's what we want to correlate with, instead of just the average 18-year-old, because we can be in a much better shape or position than an average 18-year-old is. But let's we talked about this a bit, and you brought up the resilience factor, but what I said before, and now I'm starting to think I'm hallucinating here, but I believe that once I was listening to your father on a podcast, and he was saying that we should interpret Glycan age not really as an age of a person, as a biological age of a person, but rather as a biological age of the glycan. Does that make sense?
Yes. So I think here definitions, like final definitions, are going to take time. But so how do we, so going back to, because you said biological age has failed as a concept. And I think
Well, it's just
where,
not that useful.
yeah, yeah.
Yeah.
Well, I think that's because we've been overemphasizing on the wrong markers, and this, obviously coming from it's very biased. So maybe I'll go back and just talk about.
Well, look, I'm running a competition based on biological age, so we can be frank here.
Yeah, so I think this thinking of biological age as predicting chronological age hasn't been very useful. So this was the original Horvath clock. And it's very good at predicting chronological age of a person, but not necessarily meaningful for predicting mortality, morbidity, and other more health outcomes. Let's call them health outcomes. So that's why Steve also went on to create a number of different clocks, and you can create a lot of, you can create a gazillion epigenetic clocks, and then we can debate on, which clock is the right thing. If you're talking about prediction of future health risk, and so is a risk, it doesn't mean it's not 100% it'll happen, but it's a significant risk to carry. Using glycans as a proxy for systemic inflammation and then also risk of future chronic disease and future mortality, it's a very good marker. And if your goal of a biological age is to reduce all-cause mortality and to reduce disease, then this is the best performing indication of age to do so. When we compare with other mortality predictors, we are much better without even modeling for mortality, especially on the level individual, because you need this reliable data where if you measure the same person the same day, week, months, you're getting the same result or reliable result that will move with biology, not with measurement error. And the challenge we had with the epigenetic clocks, I think this is a technical challenge, some biology challenge, but technical mainly now in the use case we have, is the measurement error. So all of the clocks are using the Illumina array, which was designed for research, and there's a 10% measurement error built in. And then if you do cohort analysis, it's great to do research, but when you bring it to a level of a single patient or client, it can be up and down 10 years, which is, within the error, but you lose meaning because you don't know, are you good, bad, what's driving it? If you do something, it doesn't give you the correct feedback. So I think that's where the age has failed. Predicting chronological age has no meaning. And if you can't reliably give a reliable measurement, it has no meaning because you can't act on it. And then the other confusion is that it's one number. It's not. It's going to, we can measure biological age, and there's 12 hallmarks of aging, and of course they're going to correlate, and different systems will, have different weighting. But there's probably never going to be one measure of age because we are going to decline in different ways. And for me, maybe immune aging is something that's better at keeping me alive, while something else is more of a risk marker. But the actual value in it is not the prediction of the age, it's the difference from your chronological age. So where are you compared to where you should be? So now we know that every extra year of GlycanAge is almost a 10% increase in all-cause mortality. So lots of the clocks before, especially telomere companies, they're limiting the range the age can go, saying it can go beyond 10 or, but we decided not to do it. We were like, we're just going to translate biology as it is.
Are you not factoring in age into the equation? That's really interesting. I've been working on the pheno-age algorithm, and then I'm like, why is age in there? What the heck is this doing here?
Yeah.
Okay.
Yeah, so we don't need to know the age to give you a glycan age. For the report and some of the indexes, which are connected to certain indications, there we reference that to age, but not the glycan age itself. That's something we call an index, or a composite of the glycans we would see mostly change with age, and then exactly how your glycans look. So you can have a 18-year-old who has the glycans of a 70-year-old because of chronic inflammation that's driven by autoimmunity or something else happening in the background. And where we see the most prediction of mortality is between age 45 and 65. So usually lots of chronic inflammation in young people doesn't mean it's going to be fatal. It could be autoimmune disease, it could be other disease, but the cardiometabolic or the cardiovascular disease mainly, and then cancer as well, is the fatal one that then starts to become more important in other age groups. And actually after 65, we don't perform as well as mortality. So maybe frailty and other things become more important as you reach a certain age bracket. So everything, when we narrow down the complexity, we lose a lot of the meaning. And that's, when you give the number. But when we explore this complexity, we start to kind of understand. And that's the challenge of how do we, simplify, give you the simplest thing, which is the number, which is a proxy. And then also the complexity behind it to decode, where is, and I can show you a report so we can actually go into those details. But what it means, if your reference is to all-cause mortality, if you are 20 years above your age, that's a almost 200% increase in all-cause mortality. If you are 20 years below, that's a 200% decrease in all-cause mortality. That's what your GlycanAge means today. And then as you go further details of it, there's more complexity, but that's a simplification.
So many people on the podcast, when we talk about biological aging clocks and it comes to glycan age, they're gonna say that it is a great marker for inflammation, but ultimately not as good for biological age. What do you say to that? Is it inflammation marker, or you would say it's more like a biological age marker than just a CRP? Or
It's immune aging or inflammaging. That's our mechanism. And I think the debate on biological age or what's the best markers for it is still out in the open. I don't think anybody's reached consensus here, and I think it's going to take us some time to. But we think it's probably one of the best candidates we have for biological age, especially due to the measurement and the prediction of future outcomes.
so, okay, then why shouldn't I use CRP instead of glycan age?
Because inflammation is so complex that with some of the markers we use in clinic now, we're not seeing the full picture in terms of chronic inflammation or general immune health, or you can even call
And
it.
glycan does.
We see a
Glycans.
lot more of it. So the immune system is immensely complex, and we are nowhere near decoding the full immune system, but it gives us quite a comprehensive picture of many things, not everything, but many things that can go wrong. And usually it's a lot, so now we have a lot of also real people stories where over a decade, 5 years, we preempted some serious health problems before anything else was able to. So I think there's a lot of value in it. No matter what result you have, there's valuable information to gain. And now I forgot your question because my mind slipped off.
Oh, CRP versus glycan.
CRP, okay. So CRP is a very acute marker of inflammation. So you would, for example, see CRP spike up with an acute infection, even with exercise. And with glycans, you wouldn't see acute inflammation. So your glycan age won't change because you have a mild infection or because you just did a intense workout. It will only change when something is chronic. So it's a way for us to differentiate acute and chronic, and it's more linked to aging.
There's another
Yeah.
blood marker that is I can't remember the name, but there is another inflammation blood marker that is starting to become more used. That is that they are saying the exact same thing, but you are saying that we should use this instead of CRP because this is showing chronic inflammation instead of acute, like CRP is going up and down. Do you know what I'm talking about? No.
Yeah, I don't know
Okay.
which one, but there's a few companies which are some are becoming commercial, but they're kind of getting ready to go to the market, looking at different things as well. And again, they're very different to what we measure, and some of the language might be similar. We don't know how they correlate because they're completely new. We do know how they correlate with interleukins, CRP, because we have those studies on glycans and CRP interleukins.
Just regarding your business, what's the business model here? Of course, selling the GlycanAge kits, but you're saying that you're doing a bunch of like research and stuff like that. So how's that? How's that? How's that work for a business? But yeah, what's the business model?
Well, our main mission is to bring glycans to people, and that's ideally within a healthcare setting. So we work with healthcare, predominantly private healthcare, and now slowly getting into public healthcare as well, to start with research, but then early integration in hospitals where two hospitals at the moment, and we do everything from the machines to the chemicals to the software to the interpretation, clinical training on how to incorporate glycomics in their setting. And the product's very different from the wellness application, which is aging, which is very broad and not disease specific. In hospitals, we're predominantly looking at prediction of heart attack and stroke. And that's where we, again, have 10, 15 years research using glycan markers and these are risk factors which are independent to CRP, BMI, all of the lipid panels. They're used for cardiovascular disease at the moment. So our mission is simple: to bring glycomics to as much of the mainstream as possible. And then another pursuit, which is more curiosity driven, is to actually understand what drives glycan aging in individuals and to catch this as early as possible and find interventions that move the needle. So there we do a lot of different intervention studies, and we spoke about some of them, but there's been 30, 40 different interventions that we studied so far with glycan clocks that move the needle in some way. And there's some which we want to study because we think they have a huge impact, but we're yet to do the trials to measure it.
Well, perhaps we'll see GlycanAge on the Longevity World Cup in the future. What is one thing that you strongly believe to be the case, but very few people agree with you on?
Ooh. Well, I mean, I do think some people agree with this, and it's a concept that's being like an interesting psychological pursuit, and that is that the biggest extender of our longevity, health span and lifespan, is not going to be a pill. It's not going to be a drug in the short term. It's not going to be any intervention. It's going to be purely psychological. And it goes back to the stress response, but the stress response is predominantly governed by how we think. And that's the part that we are exploring more, but basically that your biggest longevity intervention is your mind. And that's something you can't buy or develop a drug for at the moment. You can, yeah. So I think that's and I think actually the things that drive that in a good or bad direction are relationships. We haven't explored enough to go into that topic, but if you think of the longest running studies, there's very few, and the one that Harvard Business School was running was to study happiness, but it was running for 70 years, and they thought that the biggest predictor of both quality of life and health and longevity was the quality of your relationships. So I think that's a thing that will also be relevant to your glycans, but maybe it's a topic for another day.
The first muscle to train is your mind. But there is like an evolutionary reason as well, because as our mind, our brain has evolved because for very, very large reason is that we've have to keep track of other people and communicate with them. And I want to ask you this because I've been thinking about this. So for the longevity World Cup athletes, the people who are winning these, the patterns are pretty clear. You have to sleep well, eat healthy, exercise, and and control your vices, right? Drugs and marijuana and alcohol and cocaine and whatnot. You have to control that. So this is clear that these things there are, but there is also another thing that's so hard to put down, which is the relationships, right?
Mhm.
What are the relations, your relations to other people? But like if I ask you, um, did you sleep well yesterday? You're going to be able to answer. Or did you exercise or rest well yesterday? Or did you eat well? Like, you're going to able to answer to these questions, but what do you even ask about relationships? It's such a complex, different topic than eating well and not smoking and whatnot, that I just I'm not quite sure how do I quantify that. All right, I'm doing well on the relationship side. Like, how do you do that?
I mean, there's many psychological questionnaires, and these have been used in that study as well, and they're constantly being refined. And I think on a biological level, we still need to find those markers, or we might have them, and maybe some are hidden in glycans. We have some assumptions, but I don't think we have a definitive answer. And I think that's a place we don't focus on enough to have the definitive answers either. But we have some clues that there'll be a lot of valuable information to find there.
Weak connections or strong connections? Lots of weak connections, or a few strong connection?
So again, I don't think we know. I think that's whatever I say would be a pure assumption. And I think it's about what's causing you stress, or what's causing you some type of kind of peace and stability. And I think the close relations have the most opportunity to cause stress, and I think different things will matter at different times. um, Having a very close relationship could bring you a lot of stress resilience, and let's just say health in general. But if that very close relationship is also constantly keeping you in fight or flight for whatever reason, because it's kind of then it can be the opposite, and some people seem to do really well with community, and I think that's how they. And I actually think the people who struggle with the close relationships then lean towards the community relationships, which give them a similar type of balance. So I think it's different survival mechanisms that work in different situations. And I think sometimes even indifference is probably healthy because it helps with your stress response. But at other times, this deep connection is the ultimate thing that helps. So I don't think anybody has an answer.
Nikolina, tell your father to step aside. The new generation has arrived. You were great. Thank you very much for coming.
Yeah, no, I want to keep him alive for as long as possible, but yeah, let's see how we do.